Good morning. Suraj, slides are visible, right?
Yes, ma'am, visible.
Okay, I'll start the class. So, okay, today I'll start the new chapter called Boundary Value Testing, and this is the second chapter in second module. In boundary value testing, you are going to study some of the things related to boundary value testing. So here you are going to study about boundary value analysis, generalized boundary value analysis, what are the limitations of boundary value analysis. Next, you are going to study about robustness testing, worst case testing, and the random testing. And after that, you are going to study about the examples for each type of testing. The examples we are considering are the examples that you have studied in the previous chapter. So in the previous chapter, you have studied three examples, right? What are those? Triangle problem, next date problem, and the commission problem. And these problems we are considering once again as the examples for random testing, boundary value testing, then robustness testing and worst case testing. So for all these testing, once again we'll consider only those three examples. So boundary value testing and the remaining, what are the things I said, random testing, worst case testing, etc. All the testings techniques are comes under functional testing. So first we'll see what is a functional testing, then we'll see the examples or the methods of different functional testings in detail. So first is the functional testing. So first you have to you need to know what is a function, and then we'll see how uh, the values in one set is mapping into the values of another set. Then we'll see how we can use this for fixing the range in the boundary value testing. Okay. So the what is a set, and the values of the test are the member of the set and etc. Those things you already studied in the graph theory. So I'm not going to explain in detail about what are the set or the set elements, union, intersection, etc. That I'm not going to explain. We'll just consider here the concept of set. Then we'll use that how we will use that for the boundary value analysis and for the different functional testing strategies. Okay, so first we'll see the specification based testing is called as the functional testing, and it is due to the abstraction that any program can be viewed as a mapping from its input domain to its output range. So here in the functional testing, we are considering any program. If you consider the triangle problem, that is the program you're writing for the triangle problem, or the next date program, or if you consider the commission program, or if you consider any type of programs, here we are viewing that program as a mapping from input domain to its output range. Okay, so input domain and output range that I explained in the first class, right? In the first chapter, what is a domain? Set of all possible inputs forms the domain, and the output range is the set of output values that we have uh, specified forms the output range. So hence the program is viewed as a mapping from its input domain to its output range. Now let us consider that if you represent this one as a set, and this is also a set, and set consisting of set of elements. Here if you consider this one as a set 1 and this one as set 2, set 1 consisting of 6 elements, whereas the set 2 consisting of 5 elements. And here we are mapping the elements from set 1 to set 2, and there exists, so here we, whenever we are mapping the input elements to output elements, we are following the condition that all the input elements of set 1 should be mapped with all the output elements of set 2. So hence the program here we are viewing as the mapping from the elements of input set to the elements of output set or the mapping from the input domain to its output range. So here in the functional testing, functions uses the information about the functional mappings to identify the test cases. So why we are going for the mapping? Because we need to identify the test cases. What the test cases consisting of, that I explained in the second chapter, right? What are the test cases? So test cases consisting of set of input elements and set of output elements. It consisting of set of inputs and also the outputs, right? So the test cases here, we are in the test case consisting of, as I said, consisting of a set of inputs and set of the expected outputs. Set of inputs means the input we are giving it to the program, and the output we are obtaining after executing the program, and that output is compared with the expected or the specified output, right? So test cases consisting of set of inputs as well as the test of output. So in the functional testing, we are defining a function where the function consisting of two variables x1 and x2. So that I'm considering for the boundary value analysis, right? Two variables, but here we are simply considering the mapping from input domain to output range with the help of the function, where the function is function consisting of two variables x1 and x2, and so here for the definition purpose or the explanation purpose, we are considering only two variables x1 and x2, but we can extend these variables to any number, and that is the straightforward technique. Okay. Also, um, the functional testing that we are considering, in that we are first you are going to study about the boundary value testing, and after that in the sixth chapter you are going to study about equivalence partitions, and next you are going to study about decision table based testing and cause and effect graphs in the chapter 7. So the second module consisting of the chapter 2, chapter 5, 6 and 7. All these chapters you are going to study in the second module, okay? And the whatever the techniques that you are studying from today all belongs to the functional testing. So first, as I said, we are going to start with the boundary value testing and how to fix the boundary and how we are analyzing the boundary values. So here we are considering two conditions or considerations that we are applying for the boundary value testing. So first one is there any invalid values and that makes an issue, or can we make the single fault assumptions of reliability theory? So whenever we are applying the boundary value testing, we are considering these two considerations we are applying. First one is, are invalid values an issue? That is, whenever you are forming the test cases, and in the test case you are considering the input and the output. For the input we are defining the boundary. Then if we are entering the values other than the fixed boundary value, then that will be treated as the invalid values. Okay, so whether those invalid values forming an issue or not, that we are considering. And second one is, can we make the single fault assumptions of reliability theory? Means, so whenever we want to test the developed product, and there we assumes that there exists a single fault. Okay, that we are assuming that is called as the single fault assumptions of reliability theory. Okay, so suppose if we consider the invalid values, then obviously if we enter the invalid values, then that leads to the erroneous output. Okay, or the program may not be executed for some of the invalid cases. So then we have to go for the robust choice, because the invalid values requires the robust choice. And for the second consideration, here we assume that there exists a single fault. If more than one fault exists, or if multiple faults occurs, then we have to go for the worst case testing. So in the worst case testing, we are considering the all possibility of the input cases, and for each input cases we are testing the developed product, and that testing is said to be a worst case testing. Okay, so first we have considered two considerations. One is, are invalid values an issue, or can we make the single fault assumptions of reliability theory? If not, then we have to go for the robust choice of the test cases, and the one more testing called as the worst case testing. In the worst case testing, we are considering all possible input and output combinations, and we form the test cases, and all the test cases are to be tested on the developed product, and that type of testing is said to be a worst case testing. So, if we consider two considerations and two consequences, then it leads to four variations. One is with normally a normal boundary value testing. Second one is robust boundary value testing. So, in the normal boundary value testing, we are considering the valid input cases. So, if we have the invalid input cases, then that leads to the boundary value testing or the robust choice. And second one is the worst case testing that we have to consider for the boundary value, and second one is the worst case boundary value test, sorry, robust worst case boundary value testing. So these four variations we need to consider in the boundary value testing. So first we'll see the boundary value testing, the rationale for the boundary value testing. Industrial, commercial, and defense software all faults seem to be more prevalent when variables have values. In the boundary value testing, we need to fix the boundaries for the input and output, and here we assume that if the input values are the near the extreme values, or the output is near the boundaries, then it leads to the extreme boundary conditions. So in the 1990s, there was a commercial tool, test tool available, and that was named as simply the T, and that was implemented by using the boundary value testing, or that implemented for boundary value testing. So it is a test tool, and it is an example for boundary value testing, because why it is simply represented as T, because that was initially requested by the US Army, and later the product is merged into teamwork from cadre systems and software through pictures and anoics. So basically these things are not there in the syllabus, but you need to know before applying the boundary value analysis or the boundary value testing. You need to know when it was evolved and what is the original version, and the remaining things that you have to study. Okay, so first we'll see the boundary value analysis. As I said, in the boundary value analysis, so it is a one form of functional testing. So since it is a one form of functional testing, first we need to consider the function of what is a function. Then we'll go for fixing the boundaries for the two variables x1 and x2. Okay, so now let us consider the function f, which consisting of two variables x1 and x2, where x1 is varying between a and b, whereas x2 is varying between c and d. Now let us consider this. Here we have along x-axis we have x1, and along y-axis we have x2. These are the two variables. For these two variables we are fixing the range between A and B and C and D. So here X is varying from A to B and C is varying from C to D. If that is the case, we are considering some boundary for the test cases. Okay. So let us consider here Along the x-axis, we are varying the x1 value. So if x1 is equal, if x1 is fixed at the particular point, then x2 varies. After that, we'll change the x1 or increment the x1 value by some value. Then x2 is incremented like that. So at each time interval, we are considering the x1 value. According to that, x2 is varied. Okay. So this is the graph. Simply shows the input domain of a function of two variables. What is the function here? Function is f, which consisting of two variables x1 and x2. And what is the input domain? Input domain is for x1 and x2 is between a and b and c and d. And this forms the input domain for the function f, which consisting of two variables x1 and x2. So basically, boundary value analysis focuses on the boundary of the input space to identify the test cases. See here. So if we consider the x1 and x2, right? So here for these x1 and x2, we are fixing the boundary, right? So hence the boundary value analysis focuses on the boundary of the input space to identify the test cases. So depending on the boundary value, we can define the test cases. So here, as I said, along the x-axis, we have the x1 variable, and initially let us consider that x is at minimum value. So x1 is at minimum value. So what is the x1 value here? So x1 is varying from a to b, where a is the minimum value and b is the maximum value. Similarly for x2, c is the minimum value and d is the maximum value. Right. Right, that we are considering here. So initially x1 is minimum. X1 is minimum means that value is equal to a. Right. At x is equal to a, x1 is equal to a, x2 is varied. Right. See here. At x1 is equal to a, x2 is varied from c to d. Okay, x is varied from c to d. After that, x is incremented. After that, x1 is incremented x of minimum plus, right? And at this point, once again, x2 is incremented from c to d, like that. For each time interval, we are incrementing the value of x1 from a to b, where b becomes the x1 maximum. See here, x1 maximum, and previous to that, that is the maximum minus, like that. Okay, so test values for a variable x, where x1 is varying from A to B. See here, A to B, where A is the minimum value and B is the maximum value. See here, that is defined. X minimum plus, X minimum plus plus, X nominal. So if we consider some nominal values, then it is the X nominal, and like that, if you vary the value until this point, then it becomes X maximum. So X minimum plus up to X maximum are the names from the T2. It is nothing but we are using these range of values for the boundary value testing, where these values are defined, are taken from the T2. So as I said, we are fixing the reliability. So here what happens whenever we are considering the test cases, where we are considering the all possibilities of input and output at each point, right? At this point, x1 is equal to minimum, and we are varying the x2 value. After that, x1 is incremented. Then once again, we are varying the x2 values, like that. Here, for all possible input and output values are all possible, and x1 and x2, we are considering the values. But practically, that is not implementable, because we can't test the developed product for all the n number of test cases. Okay, so that we can't, right? That's why we are going for the variation of the method called as the normal boundary value test cases. So in the normal boundary value test cases, what happens? Here we are not considering all the values of input and output. So some values we are considering. See here, if you consider this point, or if you consider the nominal value. So what is the x1? If we consider this one as x nominal, x1 nominal, and this becomes the x2 nominal, and this is the x1 nominal, and this is the x2 nominal. Like that, how many values we are considering here? This is x1, x2, x1, x2, x1, x2, x1, x2. How many four test cases we are considering by using the reliability theory. So, as in the reliability theory, two variables rarely both assume their extreme values. So, at means the extreme values are nothing but the values which are very near to the x minimum or x maximum, right? But these we are achieving in reliability, because if you consider the reliability theory, we assume that x1 and x2 are the two variables rarely assumes or reaches the extreme values. It is not regular or normally we are not considering that, but these are all the rare values, because we say that at rare cases the inputs and outputs reaches their maximum values. So here they will explain the method how we can perform the normal boundary value test cases, or by using the normal boundary value test cases, how we can perform the boundary value testing. So here first we will this method hold all variables at their nominal values. Let one variable assumes its boundary value and repeat this for each variable. So if we are considering here only two variables, so first we'll assume it for one variable, then that will be repeated for the other variable, that is for x2. So here we'll assume that if you use this method, it reveals all faults that can be attributed to a single variable. Okay, so if you consider here, as I said, for one variable, we'll assume the nominal value and we'll repeat it for the x2. So if we this one we are considering as the nominal value for the x1, this is for x1 and this is for x2. Then the other for x1 we'll assume the nominal value and that will be repeated for x2. Okay, and we'll assume that if we use this method or the test cases for testing, and we assumes that this type of testing method reveals all faults that can be attributed to a single variable, but that is not the case, right? Practically we can't say that for any one value the error may occur or not, because once the product is developed, we don't know where actually the error occurs. Even at the nominal value or at the beginning or at the end, the errors may occur at any places. So we can't assume that by using the nominal values, it is very difficult to reveal all the faults, or it is very difficult to identify the faults in the system. So next we'll go for the robustness testing. Okay, so that is the limitations of boundary value analysis, because even if we assume the nominal value and all, but we can't identify or we can't detect all the faults in the system. So hence we'll go for another method or other method of testing called as robustness testing. So robustness testing is simply the extension of boundary value analysis. Okay, it is the extension of the boundary value analysis. So in the boundary value analysis, there we assumed only the five variables right here. Sorry, five values we assumed. We assumed five values, one, two, three, four, five values we assumed in the boundary value analysis, but that might not be work, or by just by using the five variables, it is very difficult to identify the faults in the system, and hence we'll go for the other method of testing called as the robustness testing. So it is the extension of the boundary value testing. So in the boundary value testing, we used only five boundary values for the analysis or for the testing. So we used only the five boundary values for each variable to perform the testing. But here, along with these five values, we in the robust testing, we assumes that when the extrema are exceeded with a value slightly greater than that maximum, so that we are assuming in the robustness testing. So what is the meaning of that? So here, as I said that in the robustness testing, we assumes that when the extrema are exceeded with a value slightly greater than the maximum, if this is the maximum, if the value is slightly increased, okay, here you can see that the extrema are exceeded with a value greater than the maximum and a value slightly less than the minimum value. So what happens? So we are considering these two as another test cases in the robustness testing. Understood? The difference between the boundary value testing and the robustness testing is in the boundary value testing, we are fixing the boundaries for the two variables, and after that we made the slight variations and we are fixing the nominal values for the two variables x1 and x2, and for these two variables we fixed five different values. Then we perform the boundary value testing. But the limitation of the boundary value testing is it will not identify all the faults in the system just by using the five test cases, right? That is the major disadvantage of the boundary value analysis. And there we have not considered the extreme cases of the two variables. Extreme cases means either the value very near to the x minimum or the value very near to the x maximum, that we have not considered, and we fail to identify all the faults by using the boundary value testing. And hence we'll move on to the robustness testing. It is the extension of the boundary value testing, because in addition to the five values which are defined for the variables x1 and x2 in the boundary value analysis, we are considering two more values of the x1 and x2. Because see here we assume that in the boundary values b becomes the x maximum. But if what happens, if the value is increased to some value, that is, it is very little increased or slightly increase in the x maximum, right? That also we are considering for the robustness testing. And one more is the value which is slightly less than the x minimum, that is represented as min minus. Okay, these min minus for the slightly min x min minus is nothing but the minimum value that is very slightly less than the x minimum value. And one more is x maximum plus, that is the maximum value that is very slightly greater than the maximum value. These also we are considering in forming the test cases. Okay, understood? Okay. And so here we are stressing upon the boundaries. That's why we are considering the x maximum and maximum plus x minimum and x minimum. And what is the advantage of using such variables or the robustness testing is we are finding the hidden functionality and we lead to exploratory testing. But even though we are performing the robustness testing by considering the extreme values, but what are the expected outputs? And when we are performing the exploratory testing, we need to consider whether the program is a strongly typed program or the weakly typed program. So if it is a strongly typed program, okay, so for example, the programming language such as Ada, it is a strongly typed programming language. Such type of languages, robustness testing looks awkward. Okay, for the understood, all of you following, right? For the strongly typed programming languages such as ada language, robustness testing is looks very awkward because uh, here the variable is defined to be within the certain range, right? That we have concentrated when we have defined the function with the two variables x1 and x2 and fixing the ranges a and b. If the range is already fixed, then what is the necessity of increasing the value to x maximum plus or decreasing the value to x minimum minus? That is not required, and it looks awkward in the strongly typed programming languages, because in such type of languages what happens, if we uh, give the value greater than the boundary values, obviously that leads to the invalid input or invalid input range. So hence it is not required for the strongly typed programming languages. So that is the major disadvantage of the robustness testing. Okay, understood? Any doubt in the robustness testing? Yes. So this is the diagram for the robustness testing. So here you can compare the diagram with the boundary value analysis and this one. See here in the boundary value analysis, we have considered the boundary value, and if A is the minimum boundary value, after that we are considering, and B is the maximum boundary value, and before that we are considering. Right. See here, the in the boundary value analysis, we are considering the boundary value testing. Along with the boundary values, we are also considering one more value which is outside the boundary. As here for x1 AB, A is the minimum, but minimum minus also we are considering. If B is the maximum, maximum plus is also considering for x1. Similarly for x2, we are considering if C is the minimum value, then minimum minus we are considering. Here D, if D is the maximum, then maximum plus also we are considering for the x2. So that is the robust boundary value test cases. So these forms the robust boundary value test cases. But even if we use that, but it's very difficult. Just by using the 5 or 6 values we can identify the faults. It is not the case. It is very difficult. And for the strongly typed languages, fix considering the values behind the boundary looks awkward. Okay. Next we'll move on to the worst case testing. Next one is the worst case testing. So what happens in the worst case testing? As I said, we are going to form, or we are going to consider more number of test cases. Okay. So if you consider the boundary value analysis or the robustness testing, it's very difficult to find the faults in the developed system. And hence we'll move on to one more, means if it is not possible, or if we fail to detect or identify the faults by using the boundary value analysis or by using the robustness testing. Next we'll move on to the worst case testing. So in the worst case testing, when we compare the boundary value or the robust case, the number of test cases are more for the worst case testing. See here, the number of test cases are more for the worst case testing when compared to the, or when compared to what, the boundary value testing or the robustness testing. uh, so here we'll consider if what happens when more than one variable as an extreme value. So let us consider that x1 is having the extreme value, and if you analyze the output of the system by considering the extreme value, and that is said to be a worst case analysis. Means in the boundary value testing, we are analyzing the system by considering the extreme inputs or the extreme outputs. See here, for the x1, which is the extreme cases, x minimum and x maximum. Similarly, x2 minimum and x2 maximum are the extreme cases. So we are performing the testing by using the extreme cases also, and then it is said to be a worst case testing. So when compared to other two types of testing, worst case testing is clearly more thorough testing, in the sense that boundary value analysis test cases are a proper subset of worst case test cases. So what it indicates, so if you perform the testing by using the worst case testing, so it it is the thorough testing method when compared to robustness or the boundary value analysis. And once again, the in the worst case testing, whenever we are defining the test cases, and these test cases consisting of the test cases of the boundary value analysis as well as the robustness testing. Why? Because for the worst case testing, we are defining the number of test cases which consisting of the test cases of the um, robustness testing as well as the boundary value testing. So suppose in the worst case testing, if we have only two variables, then we should have the 5 power 2 test cases. Means that is the condition for worst case testing. If we have n variables, then the test cases will be of 5 to the power of n. Understood? If only two variables are there, then the number of test cases will be 5 power 2. 5 power 2 means how many? 25 test cases will be there. So if we have 5 variables, then how many test cases the worst case should consisting of? 5 power 5. So in general we say that if we have n input variables, or if we have n variables, then it generates 5 power n test cases. But in the case of boundary value analysis, if we have only n variables, then we have 4n plus 1 test cases. How many? Only. So if we consider two variables, then how many test cases we will have? 4 into 2 plus 1 means how many? 10 cases. But here, how many test cases in the worst case testing technique? We will have 5 power 2. 25 test cases for the worst case boundary analysis, sorry, worst case testing when compared to the boundary value testing. So hence it is said to be a worst case testing. Understood? So why it is called as worst case testing? Because in the worst case testing, we will have more number of test cases when compared to the boundary value analysis or the robustness testing. So this is about the worst case testing. So along with this is the worst case testing for the boundary value analysis testing, and the next one is for the robust worst case boundary testing. So in the robust testing, what happens? We are considering the values which are behind the minimum and maximum values. Because see here, in the robustness testing, we have considered the value which is slightly lesser than the minimum value, and the value which is slightly greater than the maximum value. So if we consider these two values in the robust worst case testing, then what happens? The number of test cases increases. So in the robust worst case boundary value analysis, then what happens? N is equal to 7 power n. So if we have only two variables, then how many we will have? 7 power 2. How many? It becomes 49 when compared to the normal testing. So in the normal worst case with the boundary value, how many it will be? So if we have n variables, then it is 5 power n test cases. But for the robust worst case technique, if we have n variables, then we will have 7 power n test cases. So here the number of test cases increases. Hence it is said to be a robust worst case boundary value test analysis. Here we are considering the more number of test cases in order to identify or the detect faults in the developed system. Next one is the special value testing. So, the special value testing occurs when a tester uses the domain knowledge, experience with similar programs, and information about the soft spots to identify or to define the test cases. Understood? The special value testing occurs. Okay, when the special value testing occurs, the special value testing occurs when the tester makes use of the domain knowledge. Okay, when the tester makes use of the domain knowledge, experience with the similar programs, and the information about softs to devise the test cases or to define the test cases. And the special value testings is suitable for the or it is useful when we are performing the complex mathematical computations, and whenever we are using the special value testing and whenever we are using defining the test cases, no guidelines are used other than the using of best engineering judgment. Okay, so no guidelines are used, but they are considering the best engineering judgment experience in order to define the test cases for the special value testing. So as I said, special value testing occurs when the tester uses the domain knowledge, experience with similar programs, and the information about soft spots to define the test cases. And no guidelines are used, only they use the previous experience or the engineering knowledge and judgment for defining the test cases. And special value testing is appropriate for complex mathematical calculations, and it is appropriate for the worst case situations. So worst case situations means we are considering more number of test cases. And as I said, whenever they are defining the test cases, they are considering the past experience for the problematic situations. And the special value testing is characterized by the second guess, like the implementations and the previous experience with the similar problems or the programs. And this testing is frequently done by the customers or by the user. And the special value testing is defines the measurement, and it is highly intuitive, and it is rarely repeatable means, so that is special value testing is not done again and again. It is rarely repeatable or seldom repeatable, and it is the effective testing method for the complex mathematical problems or complex mathematical calculations. Mm. And next, so this is about the special value testing, and the examples for these type of testings that we'll discuss in the next class. So the examples we are considering for these testings are triangle problem, next one is the commission problem, and the third one is the next date function. We'll consider these three examples for different types of testing. So what are the different types of testing you have studied here? So first one is the boundary value analysis testing, second one is the robustness testing, and third one is the worst case testing. So in the worst case testing, we have considered the boundary value as well as the robust test along when we are defining the test cases for the worst case testing, right? And after that, you have studied the special value testing. So for these testing techniques, so we'll see the examples in the next class. We'll consider the example of triangle problem, next date function problem, and the commission problem. Okay, any doubt in these three testing techniques? Any doubt? Sharanya, Gaurav, Suraj, Raghavendra? No. Okay. Suraj, any doubt?
No, ma'am.
Okay. Then I'll
No,
stop
ma'am.
here itself. In the next class, we'll consider the different examples. Okay. Class ಇದೆಯಾ ನೆಕ್ಸ್ಟು?